All right, so with this first one, if you have the parentheses and a exponent on the outside, you want to basically distribute that exponent to each part in here. So you have the coefficient and then the x to the 10th. So you need to distribute this to the 4 and then to the x to the 10. So what that means is you'll have, if you're distributing it to here, you'll have 4 to the negative third, okay? And then with the x to the 10th, this is going to be what's called power of a power rule, which basically is whenever you have something that is raised to a power and then you raise it to another power, that's whenever you're going to multiply the two powers, okay? So you would multiply 10 and negative 3 and get negative 30, so that becomes x to the negative 30, okay? So once we're here, they want you to make sure you're doing all of these in the first part without negative exponents. Basically, how negative exponents work is you want to, anytime you have a negative exponent, the way to make it positive is just take it to the other side of the fraction. So that means, like, if you have a negative exponent on the top, like this, on like both of these, they would go to the bottom. And if you had a negative exponent on the bottom, it would move to the top. Okay, that's as simple, that's all you really need to know with negative exponents. Just move it to the other side to make it positive. So what that would mean is this 4 to the negative third would become 1 over 4 to the third. And then the second one would be x to the negative 30 becomes 1 over x to the 30. Okay, so anytime you have a negative exponent, you just move it to the other side of the fraction to make it positive. And then you can simplify this further by taking 4 to the third, which would be 64. So this would be 1 over 64 times 1 over x to the 30th. And then you can just multiply those two together. 1 times 1 is 1, and then 64 and x to the 30th come together to become 64x to the 30th. So that would be your answer for that first one. Okay. All right, so we're looking at this next one, same idea. Any of the negative exponents you want to make positive by taking to the other side of the fraction. So right here, this 5 to the negative second, to make it positive, it goes to the bottom. So I would still leave m to the 4th and end of the 0 on top because they have positive exponents. And then 5 to the positive 2 goes on the bottom because it was negative, goes to the bottom because it's positive. So a couple of things you can do to simplify this. 1, the 0 exponent rule says anything raised to the 0 is 1. So this basically goes away because end of the 0 equals 1. And then you can simplify this. 5 to the second is 25. So your final answer would be m to the 4th over 25. All right, so here we have the same idea, kind of as up here, where you have to take the exponent and distribute it through to each term on the inside. So that's what we're going to do here. So we have 5 to the second times 6 to the negative third, all to the power of negative 1. So this negative 1 is going to go to here and to here. Okay, so by doing that, whenever, like I said, power of a power rule, you take the exponents and multiply them. So this 5 to the second to the negative 1 means that you would multiply 2 and negative 1 and get negative 2. So that becomes 5 to the negative 2. Okay, and then our next one, we have 6 to the negative third, and that's raised to the negative first. So again, you multiply both of these, your exponents. Negative 3 times negative 1 is 3. So you have 6 to the positive third. Okay, so a couple things to simplify here. Before we start messing with the exponents, we want to make sure all the exponents are positive. So to make this positive, like we've said, you would take any negative exponent and take it to the other side. This 5 to the negative second is on the top, so we move it to the bottom. So what that will look like is 6 to the third will stay on the top, and then on the bottom we'll have 5 to the positive second. And now we can just simplify each of these numbers. 6 to the third would be, what, 216, and then 5 to the second would be 25. And then if that reduces, you can reduce it. I don't have a calculator on me, so if it can reduce, you would reduce it. If not, is where you would leave it. All right, so this next one. Couple different ways you can go about starting this. First thing I would do would probably be to just get all the negative exponents to become positive by, again, moving them to the opposite side of the fraction. So here we only have two that can be changed, which is x to the negative second and y to the negative third. So again, those will move to the opposite sides. This will move down, this will move up. So everything else will stay put. So we'll leave 27 on top. This moves. This comes up here. Okay, so I'm going to move this up here and this down here. So this comes up, this y to the negative third when it moves to the top becomes y to the positive third. Then we bring over y to the fourth and z to the seventh. Okay, and then on the bottom, we can move the x to the negative 2 down and make it x to the positive 2. And then we still have x to the eighth and z to the second. All right, a couple things we can do to simplify here. First of all, we'll go part by part, starting with the numbers. We have 27 over 3. That would reduce to just 9 on the top and 1 on the bottom, so leaving you with 9 on top. So on the next step, we have 9. This is product of the power rule. Okay, if you have the same bases that are being multiplied, which is here, this is y to the third times y to the fourth, you actually add the exponents. Okay, so y to the third times y to the fourth becomes y to the seventh, because 3 plus 4 gives you 7. So that is y to the seventh. I bring over my z to the seventh. Same thing on the bottom. So we already got rid of that because 27 over 3 reduced to 9 over 1. You can write the 1, you don't have to write the 1. X to the second times x to the eighth. These are the same base, again, same base of x, so we keep the base, and then we add our exponents. 2 plus 8 gives us 10, and then we still have z to the second. So one last thing to simplify, you want to get these z's simplified as well. This is a, I think it's called quotient of a power, where you have two bases that are now being divided. Okay, so up here, we had bases that were being multiplied, we added. You do the opposite when they're being divided. So if they're being divided, z to the seventh divided by z to the second, you subtract your exponents. Okay, so everything else will come down, so we'll have 9 y to the seventh, and then we have x to the 10th on the bottom, and then here we have z to the seventh over z to the second. So again, same base, you subtract your exponents, you'll get 7 minus 2 gives you 5, and because the bigger one was on top, that's where it will go, so it'll be z to the fifth up top.